How does insulin resistance develop in type 2 diabetes? Are insulin receptors being inappropriately downregulated, or are other players in the signaling pathway going awry? Do we understand the mechanisms behind why obesity seems to increase the risk of developing this condition?
Well, this is a mighty important question given the pandemic, the waves of cases of insulin resistance sweeping across our planet. Okay, how does it work? And basically exactly as the question outlined. Insulin. So your body's cells like to run on glucose, not solely, but it's one of the main energy sources. Glucose. Where do you get it from? You get it from your diet, not just in the form of glucose, but other molecules are broken down, converted into glucose in your gut, dumped in your bloodstream, and you now have circulating glucose, circulating sugar levels. And the goal now is to get the circulating glucose into target cells throughout your body to feed them so they can do their thing, and especially to be good at putting it into the cells that are working particularly hard at a time. In any case, so you need some sort of signal that will tell cells to take up glucose out of the circulation. And that signal is insulin. Insulin, it's a hormone. It comes out of your pancreas. It comes out as a result of a glucostat monitor in your pancreas. Your pancreas is measuring the amount of glucose in the bloodstream. Eat a big meal, levels of glucose go up, detected by the pancreas, and that's a signal to secrete insulin. Insulin in the bloodstream, what it then does is it binds to insulin receptors on cells throughout your body. And as a result of that binding, those cells pump in more glucose and your cells get fed. Terrific. So that's how it works. Insulin, in response to elevated glucose in the bloodstream, a metabolic signal, a totally logical one, secrete insulin, it does its thing. One interesting additional ripple, which is if every single evening you eat at 6 o'clock, around 5:45, you begin to start to secrete insulin. Whoa, your blood glucose levels are not rising yet because you're not eating yet. It's anticipation of your nervous system, in particular, parasympathetic nervous system, can be conditioned to secrete insulin in anticipation of food coming. So that is very cool. So in either case, this is what insulin does. What if you have a disease where you don't have insulin? This is type 1 diabetes, juvenile diabetes. Not what the question was about. Type 1 is about this problem, autoimmune chaos in your pancreas. You wipe out the beta cells that secrete insulin. You got no insulin. How do you get in trouble now? Because you have no means of getting circulating glucose to your cells throughout your body, and they're starving. You get into trouble in that way. And what's the solution? Give someone replacement insulin. Insulin injections, that serves as replacing the missing insulin. So you give somebody some insulin, and that solves the problem. And your cells don't starve. How about what we call insulin-resistant diabetes, type 2 diabetes, which is what the question was focusing on? Very different scenario. Suppose you've had enough food, you've had enough nutrients, you've had so much that every single storage cell in your body is chock full of stored energy, like you put on weight. You put on weight, suppose you have become more sedentary, you've gotten older, more of a tendency to put on weight. Suppose you've put on a lot of weight. Suppose your storage cells, in particular your fat cells, are filled up with everything. And what the cells essentially have is a ceiling. At some point, they have stored all the glucose they can, usually in a variety of different types of storage forms. At some point, they are completely full. And what your cells say, in effect, is, that's it. We're full. We're not taking up any more circulating glucose. We got no more room here. We're full up. I don't care how much insulin there is. We're not going to listen to insulin anymore. Your target cells become resistant to insulin because they're totally full and they can't take any more. What's the mechanism for this? Exactly what was posited before, which is the number of insulin receptors decrease. You down-regulate the numbers of them. And there's a mechanism by which fat stores inside, say, a fat cell will signal up to the insulin receptor molecule and yank it off there. And it's all very effective and terrific. So you've put on a lot of weight. Your cells are full of energy. They stop listening to insulin. So why do you get into trouble? Is it because your cells don't have energy now? Obviously not. You're getting insulin resistant in the first place because your cells have so much energy. That's not the problem. It's a completely different problem than in juvenile diabetes. The problem is you got all this glucose now in your bloodstream, and it's not being taken up by glucose transporters and target cells because the insulin receptors have downregulated. They're not listening to insulin, insulin resistant. You got all this glucose in your bloodstream just circulating around and looking for trouble. What do elevated levels of glucose in the bloodstream do to cause trouble? They glom up your arteries. They help to make inflammatory plaques get even plackier. There's this whole process in biochemistry called non-enzymatic addition. Glucose molecules can just start sticking to stuff if there's enough of them. And they're around long enough of a time, and they start sticking to stuff, and a piece of glucose will stick to this piece of protein, which isn't supposed to happen, and then it'll stick to this piece of protein, and they're kind of glommed up together, and you can get layers of them. What's that about? That's one of the side effects of sort of uncontrolled hyperglycemia and diabetes. You get cataracts in your eyes. You begin to get filmy crystals of proteins that are getting, hairballed together by Velcro of glucose because there's so much of it sticking together. Glucose, this non-enzymatic addition of glucose to blood vessels and clogging them up, that's where you get into trouble. So you've got two very different pictures. Juvenile diabetes, you don't have the insulin. Your cells are starving because they can't take up, they don't have the uptake signal from insulin. Take some insulin and take it up and off you go. Adult onset insulin resistance, you've put on so much weight, the cells are so full, they stop listening to insulin. The cells are fine because they got plenty of energy, but glucose circulating around and it gets you into trouble. It clogs up your kidneys. You get a diabetic neuropathy, which is to say that you got some chronic pain things that arise from that. You get into trouble. One final piece of it. Where does stress fit into this? And this is where you've got a very interesting interaction between stress and insulin-resistant diabetes. Stress. What is stress about? If you're a normal mammal, there's a physical emergency, you're running for your life, somebody's trying to eat you, you're trying to eat somebody else, you need energy right now for your exercising muscles. And what is one of the stupidest things to do with your circulating energy while you're stressed and running for your life? Store it away in your fat cells for next spring. Store it for some long-term building project. The logic of the short-term stress response is you block energy storage. You're emptying out your energy stores to use right now for this emergency. So what if you were stressed, not because somebody's chasing you for 30 seconds, but because you were psychologically stressed around the clock nonstop for years, decades on end? What are you over and over telling your body with these stress hormones like glucocorticoids? It's saying, don't store glucose. Don't store, because we're about to run for our lives. We need it. Don't listen to insulin. What lots of stress and stress hormones like glucocorticoids do is they exacerbate insulin resistance. So you get someone who's just in the ballpark of a serious case of insulin resistance where they're going to get into type 2 diabetes and hyperglycemia because the glucose has no place to go. And what does chronic stress do? It says, what a great idea. Don't listen to insulin. Glucocorticoids and chronic stress worsen the downregulation, the dysfunction of insulin receptors. So that's where you get an interaction between the two.
And that is it for episode 45.